Cool. All right, there we go. All right, hey guys, thanks. Thanks for coming. This is an awesome turnout. So my name's Eric Flecher. My co-presenter here is Jerel R. We're both consultants at Quick Solutions. In our day jobs, we specialize in what we call omni-channel and mobile technologies, right? So really kind of this marriage of mobile, business, line of business, anything that has a battery or a screen. How do we create business value out of things? So that's how we think, right? Those are the kind of challenges we like to take on. And so the topic or the conversation that we want to have with you today about connecting to things is really something that him and I, over a conversation over beers, kind of started, well, wouldn't it be cool if? And then eventually it turned into, wouldn't it be scary if? And we're going to talk about that, and we're going to talk about kind of how we kind of broke down this idea and the different elements, and kind of we built a little experiment, and we're going to share that with you today. So cool. All right, so the things. So what we're going to do first of all is we want to basically explain that in the world today, even in this room, and we'll show you this in a minute, there's a whole lot of ambient noise that we're all putting out. Ambient noise in the form of just wavelengths, right, radio frequencies, that sort of thing. In addition, we all have these mobile devices, hand computers in our pockets, right? We're now starting to wear them on our wrists, right? All that fun stuff. And so what's interesting now is with all these different devices and all these different things that are broadcasting all different times, is there ways to kind of use the stuff that's already out there in a more passive way, right? Can we learn or build systems or platforms or take advantage of the fact that all of us are broadcasting every day, right? So one of the first elements we started talking about is, hey, there's GPS, right? GPS has been around for a while, right? There's a couple of different systems that are out in, kind of working today, right? I have a running watch here, and it was actually really interesting because one of the features of this running watch is it uses both US and Russian satellites. So if I'm running in a city, right, I can get satellite reception a lot quicker. The other thing that's interesting about this watch is it has Wi-Fi and Bluetooth. So not only am I receiving lots of different radio frequencies, but I'm also broadcasting, right? As we all know, GPS has a range of about plus or minus 50 feet. So, as someone's driving down the road, it could track them or be tracked, right? Cool. All right, so geofencing, right? So geofencing is a concept or implementation of GPS, right? But essentially a tripwire for GPS, right? So a device that's location aware, that can broadcast itself, crosses a boundary, triggers some sort of notification, and things can happen, right? So this has been around for a while, since about 2004, but we haven't seen it really been used from business context until, I guess, fairly recently, right? Actually in our space, we're starting to see a lot of our clients think a heck of a lot about geofencing as one of the tools that they would use kind of in how they build their brand or bring their brand to customers. Wi-Fi, right? So, we're all aware of Wi-Fi, we use it every day, right? So obviously it brings us a connection to the internet. We're looking at it from a different perspective, right? So for us, when you combine, geofencing and GPS, well, Wi-Fi to us represents a static location, right? In a lot of cases, the Wi-Fi router itself says the name of the place, right? So in this case, we were out at Easton, there's a Panera Bread, and there's a World of Beer. We already kind of know, like, hey, we know we have a GPS signal. We're probably inside some sort of GPS geofence. Now we're at a location where we can look out and see, hey, we have a weak signal strength if we're at World of Beer for Panera Bread, and we have a strong signal strength for, World of Beer. So, all right, beacons. So somewhat of a newer technology, been around for a while. We got one sticking to this here. Got one over there, right? They're all different shapes and sizes. They have different ranges, right? So, I think the iBeacons have multiple settings that can do super long range or near range, and things can happen based on the proximity to the devices, right? These are really dumb things, right? All they do is sit there and just kind of broadcast its name or its ID every once in a while on an interval. The idea is you have an app or you have some sort of system that interacts with it or reads it, and you could trigger events based on that, right? Even more smartly, could you trigger events based on that, based on the fact that you're in a Wi-Fi or close to a Wi-Fi, based on the fact that you're in a geofence or your general location? All right, so it's just something else here, right? So the whole idea here is, I'm sure we're telling you a lot of things you probably already know, right? So, how are we bringing this in? So the intent here, right, is to say there's a heck of a lot of stuff happening, right? And these are just two Google searches we did last night when we were hastily putting together our deck. And it was just really interesting, right? So location is, a very critical piece of data, wired, right? The number of kind of smart devices over time, I mean, the growth is unbelievable, right? So, every day you pick up, another, you see another news link about, Amazon doing connected devices for, I need laundry detergent, or, the watches that we have, et cetera, right? So that's kind of the background. So what we will hope to do is kind of open it up and kind of, we're curious, does anybody in the audience, where do you think we're going with this, right? Any thoughts to, hey, we have a whole lot of ambient noise, right? We're all kind of broadcasting Bluetooth signals. There's a whole bunch of it happening right here in this room right now, right? We're all either in or around Wi-Fi signals, right? Is there anything that kind of comes to mind that you could potentially do with this information, just in a passive manner? No worries, we have an answer for you guys anyway. So, fantastic. Okay.
We can start calling people out.
Yeah. Okay. Do you want to? Oh. Okay. Here you go.
All right. So we're gonna mine the shifting here as the noise kind of changes. So like Eric said, I'm Jerel. So I'm gonna pick up from time to time and talk about these other fun things, right? I did want to talk about before we go into our hypothesis, and we will cover our device tables. So in case you guys are looking over here and you're seeing all this little cool flashy stuff, you're wondering about it. So our basic hypothesis is there is noise everywhere. There's ambient broadcast, there's observable technologies all around us every day. Your phone sees it, your laptops see it. Your laptops are actually probably the worst offender, even beyond your phones. Second to that might even be your Bluetooth connected devices who are constantly screaming, look at me, connect to me, talk to me, somebody see me. So what does that mean? So can you turn that relationship? Everyone's always talking about the interconnected web. Facebook is talking about people, how they're connected. Can we connect faces from different Facebook accounts? Well, all of that requires permission, right? What if you could just observe the world around you, see your phone, your charge, your Fitbit, they all have unique addresses, and then if I can connect them back, what does that mean? Does that mean I can identify you? Well, if I can identify you, can I identify the guy next to you because your devices are observing his? So that's our basic concept there. Can I go next one? All right. So we broke it down into our best scientific method attempt here. We're going to have a hypothesis, setup, experiment, findings, validations, all the loveliness that comes with doing this. We did not follow any sort of crazy scientific rigmarole. We didn't retest. We observed a couple times. We're like, that is fantastic. And then we went with it, right? Because it validated us. All right, so here's our setup here. The concept we went with is the world is made up of nouns. And from grade school, my son is 8 years old. He goes to school and I ask him, what's a noun? He says person, place, or thing. So what does that mean in the world around us? We have a thing, we have a person, we have a place. I'm restating it. That was fantastic, right? A thing is a concept. It is something that you can typically observe, something you can reference. A person has a little more concrete subject, and we'll go into it a little more. And then a place is an established location. So once again, we have that granularity that Eric referenced earlier with the idea of a GPS being a location, an Estimo, a beacon, a phone being a thing, and then of course all resolving down to what we want, which is the person, right? All right, so from our breakdown of what is an observer, we have the idea of an active and a passive observer, or device, sorry, not observer. We'll get into that later. So we've got an active observer or active device, which is out there looking for people, it's out there looking for things, and we've got passive, we've got an entire table here of passive things. You guys are wearing passive things, you're currently using passive things. Depending on whether or not, how this talks back to home base, right? It's even a passive broadcaster. It's saying, here I am. Can somebody know me? Can somebody talk to me? Are you going to notice me? All right. And it's all, once again, about the person. So here's our dictionary, further defined, and our relationship diagram. I don't know if that's readable. It looks fuzzy from here. It's fuzzy. But you can at least see the hard text there. All right, it's not complex. The world is not super complex when it comes to observation. You have things that can be observed, and you have things that do observe. And then we have what is really relevant to us. Just because I see you, just because you're there for me to notice you, what does that mean? What I really want to know is, can I correlate that observation to something? If I watch you for a certain period of time, I can notice habits. I can notice behaviors. I can have a time-boxed account of seeing you here, then there. Now, when we're talking about this, we're talking about it from a very obscure, non-relatable manner. So when we look at Bluetooth devices, and we built a little app here that just kind of polls, it looks at Wi-Fi's, it looks at GPS's, it looks at passive Bluetooth, active Bluetooth, and we start wondering, well, what information? We have unique identifiers to them, but we also have really specifics. That one of them is, I think it's Scott Beardley's phone, or
Scott Beardley's iPhone.
Scott Beardley's iPhone. We've got like Cyberdyne. A couple of people have renamed their devices. So we have the abstract data, the anonymized data, that is just the addresses that your Bluetooth, your Wi-Fi puts out, but also very specific. If you're not careful, you name your phone something like, Jerel's, or your computer, Jerel's computer, right? Or goats. Well, that isn't unique enough to tell that I am Jerel Haas. If I observe Jerel enough within a time box manner next to somebody I know is his associate, I can start to, Ron's iPhone, I can start to correlate that more and more, and we can put some body to it. At least that's our setup for it.
Absolutely.
All right. So here's the technologies that we used. So that way we could get the farthest reach. We went with as much in the cross-platform domain as we possibly could, and then anything that was free and open source for us to grab. We're going to go over more specifics. This is just kind of here. If you're not familiar, this is a cool time to go through our little device table here. We've got our beacons, as Eric pointed out. Our Bluetooth connected headphones. All sorts of devices, Bluetooth connected keyboards, Raspberry Pi with a Bluetooth adapter and a Wi-Fi adapter, so that way you can talk. Whoops, get back there. And we'll talk about why he's a little more special. We've got an Arduino board, which has a nice little built-in network adapter in it. We've got Bluetooth on a chip. So not only can this see and receive Bluetooth, it can also pretend to be a Bluetooth device. And it's itty bitty. Stay. All right. And even just a standard peripheral, don't you fall, a standard peripheral, even these things typically are named something when they are connected to your device. So they advertise too every once in a while. All of this is creating a fair amount of noise, as we've talked about with ambience. All right. So before we go into the experiment, any questions about our very general premise so far? Before we go into the structure here? All right. You want to go ahead?
All right, so our experiment, right? So we've organized kind of our hypothesis. We've kind of figured out how we're once in the academic speaking, right? So we figured out kind of how we're going to structure all this data that we start consuming, right? Recording. And so our very concept was, hey, you know what? Are we completely wrong? Are we just crazy? So, essentially what we did as a first step, right, is we built this cross-platform Xamarin-based app, right? And it's very simple, right? All it did was to reach out to the world and listen, right? And so we actually, in some conversations, we talked through, like, hey, why don't we go to a shopping mall? Why don't we go to a coffee shop, a conference, right? And just see, if we could pick up information. If there's enough information there to actually make some sense of it, right? So our first thought was, hey, let's go to Easton and go sit at Starbucks. Then we started thinking, hey, you know what? It's sitting and waiting and recording information may be a little boring, so why don't we just go to World of Beer and get some beers and watch as well, right? So what you see here is this is actually from, a sample size from actually last night, where we were sitting there during, kind of during happy hour, bands playing, people in there, and just started recording, right? So, it's really amazing to think, in a bar that's, 80% full, people are just sitting there not even realizing, not in the phones, they're interacting with friends, so no one's playing games or working, right? This is literally just everybody's in passive mode, technology's in the pocket, and they're still broadcasting quite a bit of information. Now, what you can't see here actually is, it does. So why don't we we wanted to show you kind of this in real life form. So we're gonna hack FaceTime, and we're gonna attempt to show you guys all the ambient noise this room's making right here. So, cool.
Hey, hi.
There's Jerel.
I'm fuzzy.
So sorry, it'll be reversed, right? And it'll be,
And it's reflecting.
let's see here if we can make it not reflect. Wait here, you gotta do it this way.
All right, I can't look at it. The same
Yeah,
time.
all right. Right, left, center. Okay, actually, Jerel, if you wanna scroll.
Yep.
So you can see here, all of these things are devices that
Just
we're
in this
reading
room right now.
just with this phone, right? There's hotspots, there's Bluetooth devices, there's people's phones, there's people's computers, there's stuff maybe out in the hallway, right? All of these items, these devices have signal strength related to them, right? They have unique identifiers, which is really interesting, okay? Some of them actually have defined names, right? Bob's iPhone, right?
Somebody took their ID and they made it a sword.
Someone made it a sword. Look at that. That's pretty cool.
Little ASCII art there for
Absolutely. I know I love, like, I live in an apartment building, right? So you turn on the Wi-Fi and you see, CIA surveillance van, right? Stop making so much noise upstairs, right? Apartment 420 is stupid, that kind of stuff. So there's all this information being passed passively that no one really sees about, right? The underworld of ambient noise. But yeah, this is just that one bar where nobody's using technology, they're actually interacting with humans. So, and that's how much noise is being made, right? Obviously this room, we're pretty focused on technology, so you'd expect a heck of a lot of stuff. But at the World of Beer, you'd think it's kind of a good sample size, right? A good sample. Cool.
The codes.
All right, the codes, right? So we've got some examples of just kind of what we've done on the Xamarin side. Joe, do you want to walk through this in a little detail, or? Sorry for the passing back and forth, guys.
Yeah, we didn't want to get too bogged down with showing slide after slide of code because that really doesn't get you anywhere. We do have a blog post. We have GitHub resources that we'll expose later on. And of course, Stir Trek will have reference to later on if you guys want to take a look at some of what we worked on. Basically, the general idea was to create a thing observer, or at least a interface for that was going to be our entry point. And then with that, we can go ahead and implement that in n number of observers. You can't really see that picture very well, but there's an Android network observer, there's an Android Bluetooth observer, there's an Android Bluetooth LE observer, or low energy observer, there's a Bluetooth or Android GPS observer, and then duplicate that on the iOS side. Xamarin does a good job of abstracting that kind of stuff out. It was just a matter of making sure that when we implemented these in the libraries, it was there. Even below that, there's a Windows Phone, and I guess it's getting the treatment that everyone seems to give it right below the fold. But it's there. We even have the Raspberry Pi here. That guy right there is observing through the Bluetooth.
Let's take a second here. So
okay.
one other aspect too, right? So up to this point, what we've been doing, right, is we've just been kind of talking through, hey, there's all these devices yelling out, even beacons, right? But for the most part, they're not interactable. They're kind of dumb. Even if it's a smartphone or even if it's a computer, they're just speaking out, right? So as part of our experiment, we're like, wait a minute. We need to kind of recruit some forces to our side. How can we be in insurgency and listen to the noise and start interacting with it in meaningful ways, right? So our first step was building this app. And so by the nature of this app, it's also an observer, but with some extra lines of code, we could make this thing an active beacon, right? We could make this thing respond to the world around it and do things, right? So based on whatever platform we might create. So in addition to that, we know that we have these beacons that just send out a number. Why don't we create our own beacon but make it a little smarter? So the concept of a Raspberry Pi being able to do that, right? So now we have a smart beacon. It represents a place. It's at a location. It's in a Wi-Fi. It could read out. It could ping. It could watch others in relation to itself and in relation to them, to beacons. And it can start to create that data set along with the one phone that we have in our system as well, right? I want to talk a little bit about kind of what we did there.
All right, so this is all the guys kind of hooked up so that way I can push code through my computer to the Raspberry and then the Raspberry to the Arduino board. And then they're talking to this guy when he's powered, all in a nice unit of work to display the different sizes that we can use. And these are all intelligent devices that can advertise themselves. They can even observe other beacons and mimic those beacons and see what kind of interaction they get out of that. So we've had a couple companies that we've worked with that have talked about, well, what we want to do is we want to be able to put out beacons around a storefront. And one of the kind of glorious stories of this is there was an announcement at South by Southwest that they were going to unleash 2,000 iBeacons. So that way every single one of the stalls, every single one of the people would have a beacon. Your phone could react to it. Your phone knows where you are at all times. And then that's where you get the idea of context. Well, since there really isn't any security when it comes to Bluetooth technology, let alone low energy, your device could see another Bluetooth, mimic it, broadcast that out, wait to see what another device does. Does it connect to the Wi-Fi? Does it try to stimulate a response? Does it try to connect? And then record that information back. So we've got smart observers, things that can push and pull in a meaningful fashion. This guy. Whoa, I gotta stop putting that so close to me. The code written for the Raspberry Pi that was using mono, so I kept it within the C# domain, but it could have been Node across the board. We didn't have to do it. It's just it happens that I'm most familiar with C#.
Okay, so we've got these devices smart. We're collecting data, right? So we're actually starting to think, hey, we're not actually pretty crazy. There's a whole lot of data out there. So what if we actually wanted to start making some sense of it? So what we've done is, so this is kind of our what if, right? So we started in the grand plan, right? Our idea was, mobile apps, smart observers, it all getting sent up to this awesome document DB. We have a web app kind of parsing through this stuff, creating radar charts, showing Venn diagrams and relationships. But of course, real life got in the way, and so we had to, kind of triage, right? But we did actually have, at this point, we did have a web app that isn't reading our actual data, but it's reading fake data that represents it. And so what we wanted to show is just kind of a, hey, maybe you guys can take this and kind of walk forward with it from here. But the idea is, hey, you can start to visualize this data and create things that are interesting out of it, right? With just the data that we created a simple data set and we put it up in MongoDB, right? Yeah. And we started visualizing it, right? And so, actually go back real quick, 1 second. So, we were using React.js here, and you could just kind of see here the nice thing about the way components get work, right? Is kind of see how we were thinking and breaking things up, and it worked really well for the purpose of kind of how we're writing the style and the pattern of our code actually starting to mimic our structure of our data, which is kind of neat as well. So cool. Oh.
Sorry, got a quick hack.
Cool. Okay. So what did we actually do? So so we ran this experiment. We got data. We started learning a little bit more about it. We kind of made these devices smart. We started thinking about it a little more. We actually started working on a way to report this information, right? We have a data store to store all this information, one that you could write any number of apps, do predictive analytics against, right? The concept of marrying that information against social data is interesting, right? So what we did, right, is these are the things we've done, right? So we've got all these items done. What we didn't do is connect like the full stack, right, like I said. But yeah, okay. Yeah, the next guy. So why is this? So there's two perspectives here, right? So one, it's kind of neat that all this is going on. It's also rather terrifying, right? We have a couple slides going on after this, and we'll just go to the next slide here. But so it's awesome. I think this is really neat because maybe we haven't figured out exactly how to make it secure yet, right? But everything's telling us that there's going to be just more and more of these devices, and the more of these devices that we're just going to end up carrying around with us, even if we don't even know they're with us, right? So how many, you could see maybe 4 years in the future, we're at a conference and they might be giving us some item that we'll put in a bag, and we'll forget it's in our computer bag, and it'll be there for, how long, right? Is that thing going to be broadcasting in some way that might identify you, right? It's going to change the way we kind of live in our homes, right? So, Amazon announced that buy button, right? So like if I'm running low on detergent, I click the Tide button and Amazon starts shipping it to me.
Or Alexa, you can just ask for her and she'll buy you stuff.
Yeah, I mean, so you've got all these devices that are just getting smaller and smaller and smaller. They're taking over the analog dumb devices in the world, and they're replacing them with smart devices that connect to stuff. And so as a result, there's going to be even more ambient noise, right? So interesting point here. So after a few beers, we were like, hey, we wanted to kind of show us something awesome. And here's something awesome, right? Everybody's seen these Teslas. They're fantastic. But a little sidebar. We could not find any photoshopped version of a Tesla with Nikola Tesla driving it. And I thought that was really interesting. When you consider the internet and just how creative it is these days, that didn't exist at all. And we actually spent a little more time than we needed to trying to find it. So then we actually did a little bit of, photoshopping in PowerPoint ourselves.
Maker way. If it doesn't exist,
that's right. Yeah. So there you go. You see right now all these eyes. This is the first actual photoshopped image of a Tesla with Nikola Tesla in it. So that's pretty neat. Someone actually made a joke earlier today. I won't take credit for it, but there was probably some Thomas Edison, photoshops with Teslas in it. So cool. Big nerd joke. Obviously, Nest, right? So Nest is a great example of taking things that are analog and making them digital, right? And so, as we kind of watch the tech news, I think this is something you're going to see a heck of a lot more of, right? The big next thing, the big surprising thing is going to be something ridiculous that is now digital, right? There's those iRobots, right? Taking a vacuum cleaner and making it a thing that drives around your floor and provides entertaining cat videos, right? All of these things in our lives are going to become digital. It's going to be a matter of time. Somehow someone's going to figure out a way to make some money out of it, right? And then, just announced this week, right? So you've got some of the biggest players in the world announcing that, this is their commitment, right? So it's pretty interesting. It's pretty amazing stuff. So, our goal was, of course, not to try to figure out exactly what to do with this information, but to start to maybe take an archetype or a skeleton of, hey, we've got all this stuff happening. Is there a different way to look at this, this problem or this opportunity?
All right. Because apparently my role in life is always to be the Debbie Downer of the world. All right, so we've talked about how awesome it can be, how we can connect, how you can have your thermostat react to you coming home, not coming home, seeing you coming, noticing your life patterns, your thermostat. Right. All right. So where does this go? How can this go terrifyingly wrong? Right? because that's me. I am the terrifyingly wrong guy. When we originally talked about this, we're talking about, we can observe people, we can build patterns. Now we're talking about custom advertisement. We're talking about other cool things. Well, what if I could see your face? What if I can observe you through, obviously the Kinect is a great device. It's also a giant device. However, there are plenty of small cameras, and facial recognition does not take a large camera. It actually doesn't take a very high def camera either. So we can observe you. So we not only do we know what devices you carry, we know what your face is. So how do we find you? How do we know you? How do we look you up? Well, you probably exist in one of these social networks. Do you exist in Facebook? Is your picture out there? What about LinkedIn from a professional life? Can we correlate all that digital data, all that ambient noise, back to something that actually has a record of you, like LinkedIn or Facebook, that can give us a concrete understanding of that person, that person's name, that person's physical relationships? We know you went to World of Beer, or we know a device named My Sword is really cool Wi-Fi went to World of Beer. But we also know that while that device was there, 5 other people were there because we recognize their faces. We can then, of course, scan, look for that face, find the 5 people, wait for that occurrence again. Once again, we're talking about those occurrences, those time-boxed events. So something started, something ended, somebody walked into the bar, somebody left the bar, picture was observed, event happened, once again. So we can correlate back those records. We can observe you through Bluetooth. And of course, the terrifying comes in when we start talking, well, what about government? As Eric showed within his last slide a few steps ago, the government, for all of its infinite wisdom, has decided that it is going to be the largest backer behind IoT devices. All right, so what does that mean? Well, in theory, that creates a nice connected web of relationships. We know who you are, we can see who you are, and we know the history of everywhere your device went because we know it's your device. We may not be able to see you, but we know because your device is out there screaming to the world, I'm here, somebody look at me. Isn't that great? So you thought you were being sneaky. Meanwhile, your phone in your pocket is out there saying, hey, Gov, what's up? Yeah, I'm just over here in this weird warehouse district in the middle of nowhere. Not doing anything bad. Why? Is that something wrong? All right, and then, of course, we've got a couple more images that are a little self-explanatory. You're out there making comments. You know, how does that affect freedom of speech? Is there going to be a chilling effect associated with everyone's identity being public? It's one thing to know that, well, yeah, so I went to the bar last night. It's another thing to say, well, I commented something really dumb while I was at the bar. Or I was on a website. So does that correlate back to your browser history? We get a little more sneaky when we start talking about these smart devices, not only looking at the Wi-Fi, but then crawling the Wi-Fi for public exposed computers, right? It's one thing just to look at the Wi-Fi, it's another thing to crawl that network. We crawl that network, now we see your computer. Does your computer have a publicly shared folder? What can we get from that? That gets a little more into the legal ambiguity, right? There's, hey, I'm advertising everything, and then there's, hey, not only were you advertising, but I decided to go through your unlocked door and go through your closet. Hope you didn't mind. All right. So that's our terrifying. Go Internet of Things. All right. So this is our projected outcome, or at least the ideas we came up with. And this is our positive. This isn't our crazy, terrifying, Skynet knows what you're doing. And because it's a positive thing, that means I'm going to switch it off.
Cool. So thanks, Jerel, for that. That was fantastic. So what's actually not showing up here very well is we have another bubble. Not that it needed any more circles on this diagram or this picture, but it's a blue kind of haze that kind of encircles the phones the raspberries, the beacons, and the Wi-Fi's. And so, to end kind of how we are thinking through this and breaking to stuff, we thought it's just really interesting to know that now that we have these ambient things broadcasting, and we have a solution that's a static smart device, and we have the start or a canvas for a mobile app that or a plugin that you could put into all the different mobile apps that would interact and be smart for you, like dynamically smart, right, in different contexts. There is some interesting things you could do, right? So there's, you can go on a list of the current startups and say, is there value with this type of setup, right? So, maybe one of the first things we started about was, hey, dating apps, right? Is there a new way to do dating potentially that involves, some people have the same interests and they're in the same bar and they'd be interested in getting a notification, hey, there's somebody here like you or that would be interested in talking to you. Do you guys want to meet, right? There's the professional networking aspects of it, right? So, as we walk around this conference today, if one of our to-be future apps or iterations of this was listening and marrying up LinkedIn information with other LinkedIn information, and we didn't have time to talk today, but you're at least able to say, hey, you guys passed by each other, and by the way, you have a similar schedule throughout the weeks. Why don't you go meet at this Starbucks that's both convenient for you to go talk about something, right? Is that too creepy? I don't know, maybe. But you could do that with this setup. This is the foundation for that type of thinking, right? We're using all these different devices to triangulate, right? So, there's no Wi-Fi at this conference, right? But what's really interesting is if we had a few devices here that was running a 2B state of our software, right? We might be able to say with some reasonable certainty that, a few people over in this section of the room, are interested in cloud, and the back of the room on the left is interested in security, and, why don't we reorganize the room so that we could have, a good balanced conversation about stuff, right? There's just so many different ways to try to triangulate and do kind of micro, I guess, kind of navigation and geolocation, right? The interesting thing about this as well is, as we go into buildings with roofs, we obviously don't have access to GPS. So we found ways now with this kind of full stack of GPS at the highest level, and then geofencing as a tripwire, and then Wi-Fi as something that represents a place, right? And then beacons that represent sub-places inside that place. And then our smart Pi as something that interacts with stuff, but it represents also a smart place. Now we have phones that move around. They represent a person. And as they talk to all those things, we could, you have all these different levels, of kind of who am I, where am I, what am I around, right? It's kind of interesting. We're doing some work now with some clients that involve geofencing. And, there's actually it's actually a bit of a pain right now with geofencing because it's very static. It's not a dynamic thing that you do, right? So, if you're trying to geofence every Starbucks in the country, right now the best solution is to, go find all these addresses and, do circles and make radiuses and then go test those radiuses, and, that's a very manual process. But what if, what if there was a dynamic way to create geofences that kind of pop into existence when they're needed and pop out of existence when they don't have to, right? Or update as things progress, as businesses close or open, right? That sort of thing.
And the dynamic geofences go back to that idea of a time-boxed encounter. So you're leaving a Wi-Fi, you're entering a Wi-Fi. Wi-Fi has a specific range. You can start to calculate that. We actually, the guy on our team that is doing or was exploring the geofence is sitting over there. I think he's falling asleep. Hi, Tony. So he could tell you that they had to crawl through websites and they had to use all sorts of fun methods to hunt down the addresses of the places, let alone then look up the geofences. So what if you could just establish a geofence by knowing where people went, what they observed when they were already there? And is that even a little more important than a physical location? Do I really care that I have the exact layout of Easton Down or of a Panera Bread or whatever, or do I care that it's within what I would consider to be a hot proximity to there? The polygonal structure may not be as important as the idea of observation or I am within an observable range. Something you can't get out of a geofence, but something you absolutely could get out of time-boxed observations. That's the pitch there. All right, so this is us. We can talk a little more about specifics with you guys if you want to go over. This is who we are. This is how to reach us on the Twitters. And we didn't put any of the rough code or anything out there because we didn't want to get too bogged down in it, not knowing kind of the range of experience of this group. But if you guys want to go into anything specific, if you guys want to talk about anything that is still questionable in your mind, now would be a great opportunity to do that. Yes, sir. It completely depends on the technology that you observe. So, mhm. All right, so the question was, when we're observing the devices, can we get a rough idea of the directionality and the range, right? Yep. So, and that does depend on the technology. Obviously, with GPS, yes. Yeah, 100%. But we're in a building and it's sheltered and we can't get a satellite. Wi-Fi, you can do rough calculations that you're within a proximity of the broadcaster. So you can look at the dBs that are coming out of it, how strong is that signal to you. That gives you a general idea that you're within a radius of that Wi-Fi. Bluetooth LE, though, will give you that. It says, it took me this long to get to you. I believe you are this far away from me. And not only that, I believe you are northeast of me. So it depends on the technology, but yes, if we are talking at least GPS and Bluetooth, then we can definitely start narrowing that out. And as Eric pointed out earlier, triangulation helps too. So I know you're there, I know he's there, and I know she's over there, or at least I know you guys are around each other. If I can find out that that observable location is at this GPS and I have a rough idea that you guys are away, then we can start triangulating and getting that better approximation.
And additionally, how far you are from a smart device like this, right? Because it's reading you as well.
Yeah, he fits in better because this one will bounce the signal to you. It knows where it is because you told it where it's at. So as long as somebody hasn't moved it around somewhere else, having that stationary, that one point of focus helps, of course, with triangulation. Or if you can put 3 in a building, even the better. Mm-hmm. Oh, yeah. In fact, well, if you're willing to create your own IoT concept even, outside of just the standard GPS, we've talked about available technologies. You go beyond that and you start talking about like radio location and, you know, I'm able to broadcast my inside GPS. Then we can start really building a web. And that's, of course, outside of the standard, but if you had an emergency situation, maybe you could turn something on that would give you a higher level of or a higher level of accuracy. All right. More questions? More thoughts? Yes, sir. One going up. That guy there? What is that? Yeah, you're right, it's percentage of growth. All right. Sir. What is the weirdest thing we've seen connected to the internet? Did we show you the little Playboy picture? Yeah, there are certain devices that are Bluetooth controlled that probably shouldn't advertise what they are. Maybe have a little more sensitivity to their name.
Either that or there's like another underworld that we're not aware of.
Well, there you go. That goes with the advertisement, right? You happen to have the device. So does meh. Maybe you guys should start going over there. And it's one of the ideas we kind of had if we'd had a reliable network would have been to try to place some of the raspberries around the room, hunt down some data around you guys and try to have light colors that would tell you where to go based on what your phone name is, some sort of algorithm. But we were worried that we'd put these in there and our poor little mobile hotspot would die fast. It probably would. All right. And that does kind of go into that speed dating idea, in which now we've got, instead of telling everyone to rotate, you just walk in a room and you just get a natural hurting light. Okay, now it's terrifying again.
Or maybe it's an easier way to do the, count 1 through 7 and one's over there.
There you go.
It's not a new way to solve that problem. That was a good analogy.
All right. Any more questions? Yes, sir.
More of a tools question. How's the development experience with Xamarin? I saw you had an Android project and an iOS project.
Mm-hmm.
Are you able to reuse a large amount of your code, or are you really writing specific code for the platform? And then did you have any hurdles with debugging and any sort of issues that came up on one device or another not actually being in native languages?
All right, so the question was, how was the experience with Xamarin? And then were there any major issues or annoying issues? All right, with Xamarin's come a long way. Back in the day, the old idea was to do linked files. Now you can do you can share your code up to the point in which it is a direct interaction with the native library. So what I had a thing observer. That thing observer had a base class that had the basic polling structure built into it, and then it was just up to the different native devices to implement or to extend that class and then just plug in the on observe, what did you see, and then just feed the object back. So it was a huge amount of code share, except for where I'd had to initialize Android specific Bluetooth stack, iOS's specific Bluetooth stack, and then there are some compatibilities or issues between them within side of, we'll say, the Wi-Fi stack. Android, when you ask about the Wi-Fi, Android said, here you go. Here's everything you could ever possibly need to know about a Wi-Fi. The name, the distance, or the rough power. When was the last time you saw it? What was its SSID? Blah, blah, blah. iPhone was basically, its return result was, here's a Wi-Fi, here's a name. Come on. So the stacks are different, and there are things that you won't be able to overcome, obviously, because it's what they expose. All right. Sir?
Was your Raspberry Pi, you said it was broadcasting, but was it also capturing and uploading to shared DB?
Yeah, the question was the Raspberry not only observing, but was it uploading? Absolutely. As it gets to be a smart device, it can look at you and say, ooh, I just saw that you're a Bluetooth. Now let's poke you for characteristics. Can I get what kind of device you are off of you? Once I know that, can I pair with you? Which is even worse because there's only 3 or 2 pairing codes, 000 and 123. So as long as your device is set to pair, it can ask and keep asking. And once again, no security. So then I can connect to it, and once I can pair, if your device is set to pair, we can start crawling and then uploading that information in. Yes, sir.
Sorry, just curious, have you tried having multiple Pis and then doing some kind of stuff where you're recording which device is capturing and then doing some triangulation based off that? Or is that just more of like a thought you had?
That's a thought that we had. We had 2 Pis observing. That the triangulation algorithms are there out in the world, but we just never went through implementing them. If we were to continue to develop this, we'd probably start pushing it into more of a, I know, buzzword, right? Big data center, like a Hadoop or an Azure event bus that can just consume that data, and then we can run analytics on it using someone else's smart idea about how to analyze. So, we can observe the things, but are we the correct people to correlate that data? Maybe not. All right. Any more questions? The beacons are to be observed. So they're out there to bounce off a device, and then that device will say, ooh, I've seen it. And then sometimes what you can do is you can ping that device and say, what have you seen? And now you know that they're close to your beacon. So they're pairing with a smart device. The really nice thing for beacons typically, though, is your app is already ready to observe beacons. This beacon technology has the idea of the product code in it. So unless your device is going through each one of those unique identifiers and saying, hey, I'm not just looking for beacons, I'm looking for this kind of beacon, this major version, this minor version, there's less chance that you'll just randomly observe beacon technology. But if you are observing for it, and if you're mimicking a well-known beacon, then you can try to ping back. Get a little idea. Yes? No.
Something else that we kind of thought through, we didn't explore much, is as we travel down or travel into more precise kind of definition of location, right? The next logical step besides Bluetooth would have been kind of near field type stuff. And so could we turn one of these guys into like a smart surface or table if someone put their phone here? Like, is that information that we'd want to keep too?
Do that at a bar. You just casually put your phone there and it's like, yep, I know you are.
Yep.
I want you to know.
So, it's interesting, right? Because you have all these different technologies that kind of show varying levels of precision. And so at that level, when you start thinking, okay, I have all these different tools, I guess your creative mind can wonder how you could use this information or this structure, right?
I think we're getting close to food time.
Cool. Any other questions?
How do you guys feel about the applications for home security and like the low energy Bluetooth and home security and like locking and alarms and stuff like that?
So the question was, how do we feel about the applications for like home security, that sort of thing? We haven't really looked too much into it, unless you have. That wasn't part of our conversation really. Like, in terms of walking up to a door and unlocking the lock of the door, right? I mean, I think that's really interesting. It's another example of taking analog things that we use in our daily life and making it digital, right? So, I bet a security, professional could probably have an opinion of it one way or the other, and I bet depending on the day, they might say it's really scary or really cool. But it's interesting, right? Because you have all these different things now that were benign objects that are now broadcasting, and so.
There's actually a deadbolt manufacturer right now that does that, and they use Wi-Fi technology. So it's a Wi-Fi broadcaster, and you can actually program it for like one-time entry as well. So it's out there. It's in the world.
Yeah, I've seen a couple projects out there that have used a Raspberry to do all that. They have the whole center set up for Wi-Fi observation or NFC, however you want to handle it.
I mean, I think there's a lot of interesting possibilities with those type of technologies, right? So every holiday we hear the stories of how many of people following UPS drivers and stealing packages, right? Is there a way you could use this technology to let a UPS driver open your garage door and put it in and close the door and leave, right? Is that an implication of this technology that you could use, right? I don't know. It's possible, but there's just so many interesting things you could do nowadays with this. So, but really, this is where why we were so interested in it, and why we chose not to be not to hyper focus on the technologies is, we're now starting to see, hey, there's all these business problems out there, right? These analog problems out there, and how do we approach it from a product perspective? How do we try to create value with the tools that we use on a daily basis? And that was really kind of the spirit of kind of what we were doing here. Yeah.
Did you mean to put World of Beef on your slides?
Did it say beef? That's a bummer. Typing fast. Well, we approached World of Beer and for sponsorship dollars, and they said no, so we changed it. Yeah. Yeah.
What kind of technology do the beacons use as far as how do I detect a beacon?
Just low energy Bluetooth, right? So they have a small battery in them, and they all have varying shelf lives.
The CPLE is what I told
Okay. Cool. Well, I think everybody's hungry.
Yeah, they're going to stay in here for.
Awesome. Well, thanks, guys. Thanks for your time.
All right, thanks. Real quick, guys, stay in here for lunch. We'll be setting up here in a couple minutes. If you are going to leave, please leave to your right. And also, reminder, if you did get a +1 ticket, go to registration to pick that up. Great, thank you.